Richard Brown, and he wants to discuss a little bit about his work on drones and moving in to the problem of the flying car. So can you outline when you started to work at NASA?
I started working at NASA Ames Research Center in November of 1992. So I have a 26-year history there. I have worked on primarily flight simulation. That's not so much for training. We did some training, but mostly it's for human factors. What are human factors? Human factors are how does the pilot interface with the cockpit. We add a new display to the cockpit. How does the pilot interact with it? That is, let's say there's a flashing light or a flashing display or a display he can't read. How would he interface with this? Maybe he doesn't see the display at all. That's the type of work we did. We also did experiments like how long can they go without falling asleep? This is known as fatigue. So we had a fatigue study, and we'd actually measure with a camera, we'd measure the eyelid droopiness as well as heart rate and brain function. We had some probes or sensors on the brain, on the scalp. And so we would measure these indicators to see how sleepy they got. And we ran a flight, I think it was 24 hours from LA, flying nap of the Earth. That takes you by Alaska and down by Japan all the way to Singapore. And Singapore is a flight that's so long we wouldn't recommend it, but we did it as an extreme situation so that we could find out when the pilots conk out. And when do they conk out? They conk out, they fall asleep, well, a little before that, so that's an extreme flight. So we put down recommendations about how long a flight should be. So that became a report we sent to the FAA. FAA is the Federal Aviation Administration, and they are in charge of our national airspace. National airspace is the NAS, National Airspace. And I also worked with drones later on. About 8 years ago, I started working on drones. And why did we need to work on drones? Because the military said we cannot fly our drone from one military base to another because it flies into the national airspace, the NAS. The FAA said we don't want them there because we don't know how they'll fly or interact with the other airplanes. We think they're too small. They will be seen just a little bit by the pilots. And it turns out that the Predator is one of the military aircraft, and when we sent it overseas, it shot down some people, and it's used as a weapon as well as reconnaissance. And the Predator has a really long wingspan, and the military said if I ship it on a truck, we have to close down the whole freeway. It's not easy to move this airplane because of the size of the airplane. So it's very expensive to move a drone from one military base to another. Some people said, well, wait a minute, what if they're spying on us? Well, we already have police helicopters and jets, all kinds of military aircraft we see flying overheads, and so they could be spying us already. So it's really not for that. They just simply want to fly it in their own airspace. The military has its own airspace called MOA, or Special Use SUV, Special Use Areas, SUA, Special Use Area. And we also have MOAs, MOA, which is Military Operation Area. Those are areas that are outside the FAA's jurisdiction. Sometimes they go together because they're airports that are right near military bases. So they kind of overlap a little bit. But the point is that the military primarily wants to fly their drones inside their own airspace for doing their experiments or practice or training, and they need them there. But, so it was cost prohibitive to move the drones from one place to another, and they said, why can't we just fly them? So FAA came to NASA and said, help us figure this out. How can we fly them in commercial airspace without causing a collision or a conflict? So we have collision detection and to avoid conflicts. And so we would do things that would calculate the intercept course and see if the two courses intercepted. We would monitor that, as well as flying with it with spotter planes. and these spotter planes would fly next to it or just fly along, and they kind of knew where it was, and FAA might not tell them until they got close to see if they spotted it. And so we did that. So that all happened in a military area, a military operation area down at Dryden. Dryden Research Center is right in the middle of Lancaster County, where we landed the space shuttle. And there's a military base there called Edwards Air Force Base. So that area is under the military jurisdiction. And so we were able to fly the drone there along with our spotter planes, chase planes. And then we created, simulated traffic. We took a typical day flying into San Francisco, and I translated that traffic into, this is in the computer, not really there, but in the computer, on the simulators, we were able to move those traffic in to land at Edwards Air Force Base. And so this is a really interesting experiment, because this showed how when you land there, how a drone can interact with very, very heavy traffic. So when you're flying into San Francisco or another big airport, you see all the airplanes around you. Sometimes planes land right next to you. It gets really, really complicated there. And the FAA has to make sure no accidents occur. So because of that, we had to run these experiments and try all kinds of different things. But main thing we knew about drones fly slower and lower in altitude than the commercial aircraft. Commercial aircraft typically fly at 30,000 feet at cruise, and then they're coming into the terminal area toward their landing runway, and then they come lower, lower, lower. So how are we going to keep a plane safe? You have the general aviation airplanes as well, which are Cessnas, Barons, even CRJs sometimes fly. Usually CRJs we fly high up as well, but they are smaller, and they call them puddle jumpers as slang. They go from one small airport to another. And so how does that interact? And so we had to use spacing. We just said, well, we'll keep airplanes so far away from this airplane, or we'll fly it a little bit higher and away from, making sure that there was never a conflict. And so doing experiment after experiment, that is scenarios where the airplanes would come into conflict with the drone, or Predator is a type of drone, which is really an airplane that is not piloted. We call it UAS, Unmanned Air System. And it's a whole system. Unmanned Air Vehicle is UAV. That's the actual Predator. But the system involves a remote control station that controls the drone from the ground, much like a hobbyist would fly his small drone from a small remote control. But these we call them ground stations, and they have big antennas, so they can fly, they can fly many miles away, like in another country. So these remote controls are really high tech, and they control this drone all over the place and many miles away, and much higher altitudes than a hobbyist would send an airplane or a hobby. Now, the hobbyists have gotten in trouble with flying small drones near airports, and one flew into an airplane engine. And when it flew into the airplane engine, it caused the engine really to malfunction and get damaged severely. So the airplane itself had to fly back, had to go around and come back and land at the airport to maintain the safety of the people on the airplane. So this raised awareness that drones were now becoming a threat. This is similar to bird strike. We've had bird strikes where flocks of birds will fly into engines. So that happens. It's not very common, but it does happen, and we try to avoid bird strikes. But the drones, people are intelligent enough to know don't fly it near airports. So we had to put restrictions on that. That was really not a problem before. Suddenly it became a problem. But that's at the terminal area where the plane's taking off. So the plane could be at 1,000 feet or even 200 feet just taking off, and up goes the drone and into the airplane engine it goes. Maybe a hobbyist is trying to photograph airplanes coming and going. And so because of that, drones became noticed by the media and by everyone that this is a problem, that drones can affect air traffic. But now the drones that we're talking about, the military has, are bigger, and they're much more like a small airplane. not like a commercial airline, but more, some have longer wingspans than a Cessna, but a little bit longer than a Cessna too. But generally that size, and because they're smaller, but you're in the commercial airspace, the general aviation would also need to worry about this. So we were checking that, the general aviation being your small airplanes, your private airplanes, typical person can buy an airplane and fly that kind of airplane. The CRJs, the regional jets, they sometimes fly at lower altitudes, but typically fly high enough that would avoid conflicts with the smaller airplane, the drone. So the drones themselves are hard to see. So we were looking for, maybe we need to add more lights to the drone, make it more visible. What did we need? And of course we had electronic surveillance, radar that would spot it. And there's also ADS-B. ADS-B is a radio that is like a transponder, and it sends the position of the airplane to the other airplanes. And just having a simple radio receiver, you can get the positions of all the airplanes around you and show them on a map. And so the pilot himself can see the conflicts coming. So ADS-B is not required in the US yet, but we're working toward that. In Europe, ADS-B is required. The actual acronym for ADS-B is somewhat convoluted, but it doesn't mean much. That's why I don't say what. It's just think of it as a radio transmitter and receiver and broadcasting this information, broadcast the name of the flight. And we already have transponders, but transponders usually just have a signal that they are there, as opposed to this information. They don't have the GPS position on it. But the ADS-B broadcasts a GPS position, so you know exactly where it is. So the idea is, what methods may we use to separate aircraft? What methods may we use to avoid conflicts? What methods may we use to avoid collisions? And so this is the central point of our research. So at the end of the day, the experiments were successful. And about 2 years ago, we had a successful flight. They allowed the drone, that is the FAA, gave NASA, gave the military, it gave the military and NASA, a waiver that allowed the drone to fly from Edwards Air Force Base close to San Francisco, into San Francisco airspace, which is around Fresno, a little bit north of Fresno. It flew, and then it came back. And there were no problems, and it was so successful, the FAA said that concluded our research, that it's now safe as long as they follow those requirements. And the FAA still needs to grant waivers, but each time the military will get a waiver and fly their aircraft safely to the other military base.
So they had to have spotter planes, is that right?
Right, we had spotter planes. Now this experiment was without, that's a good point, Murray, this experiment was without the spotter plane. All the research I did was with spotter planes, but when they flew this airplane, they flew it without a spotter plane, and because they said we don't need it, so let's see how it goes. And it was very successful. That's a good point. That's what the news article said. And that was, music to my ears, because that means my research was successful. And so now this leads into the idea or the concept of the flying car. The flying car would use similar waivers. Now, one of the problems of the flying car is that there will be more of them. That's if we use the flying cars in the commute areas. Right now, people get flying cars. The one flying car right now on the market is the black fly car, and they are being used mostly in rural areas. They fly about max speed of 62 miles per hour. Why are they so slow? They're slow because it's safer. Safer to fly at that slow speed, and they fly for about 25 miles. You say, wait, that's not far. Well, in San Francisco, if you fly from Danville right into San Francisco, Danville is about 25 miles as the crow flies, and a large percentage of the Bay Area is within that 25-mile radius of San Francisco. So all this air traffic could then fly in. People further out would have to drive to a parking garage, or maybe we'd have a series of flying car stations that you could puddle jump from one to the next as a commuter vehicle. But for a farmer, I think some people might even rig up what do they call it, fertilizer or insecticides that they spray from airplanes. They might even rig that up. I don't know if anyone's done it, but it's cheaper than the airplanes or the helicopters, and safer. And from what I understand, you can just tell it, click on the map and say, I want to go here. And you don't need a license. The reason you don't need a license is they fly themselves. You don't need to do any of that. Now, if we are going to do the flying car in our national airspace, we need to have FAA approve it. And that means that you would have a computer, onboard computer, that would, when you click on it, you need to have a place to go. You need to say, I'm going to San Francisco and I'm going to go to this parking garage. Parking garage could be on the 35th floor of a high-rise apartment building or high-rise business building. And once you allocate that space, because it's imperative you have a parking space with a charger. And so without that, you would not be able to go. And that's would be different than the farmers. The farmers are just going around their farm. They can buzz around, and it's up to them.
Okay, moving along from farmers, what about somebody using the flying car as a commute vehicle?
Okay, well, in commute, that's where I was starting to get to, was that the commute is much more dangerous. Farmers, of course, have open grazed land. They only have their own buildings and property to worry about. But once you start flying in over a town, then you could land on something important. If you're in the town, you can land on someone else's car. You can land on a person. You can land. So there's all kinds of things. It's similar to us driving. We can hit things, but the difference is that it all needs to be controlled. The flying car, you don't need a flying. The reason that you don't need a driver's license for this flying car is because it flies itself. It's autonomous, and you simply tell where to go. Now, then in the city, we will have to have it send. That is, let's say, similar to finding your directions on Google Maps, and you'd have an application be sitting there at a computer screen in your car, and you say, I want to go from my house here to the grocery store. So you click on the grocery store, and it says no parking spots available. If it says that, you're out of luck, because you need to have a parking spot where you can land safely, that's allocated for flying cars, and that would be reserved. So you click on Safeway, found available parking spot. You click on that parking spot. This files a flight plan with the FAA. FAA would then approve it, and then they say, okay, looks fine. There's not like 100 flying cars in it that way. So it knows it's safe. So it approves it, and then you hit go. Then when you hit go, the flight plan says active to the FAA, and the FAA tracks your vehicle. Why does it need to track your vehicle? So it knows if you're going to hit another aircraft. So your flying car would be out in a safe spot. You would have to have all this, verified by the FAA. They would probably have to approve your parking spot. Maybe the city would do it, but they would be in league with the FAA. Your parking spot is free of trees and wires and all this sort of thing. So you'll have to have a parking spot in your yard or wherever that is free, safe, that won't run into something. So then the flying car would know how to navigate this yard by just going straight up and then out. So then when it comes back, it follows the same route. It would be straight right above and then right down into your parking spot. So the flying car needs to know if it has a safe place to land. And so that all would have to be managed. So when you click on Safeway, do we have available parking spot? Yes. You hit it, zip, up you go, down to, and then down right over the parking spot and just land right there. And so that would be very, very quick getting to the grocery store.
And the FAA is in charge of that.
The FAA would have to be in charge of it. Now, later they could create city jurisdictions and air traffic controllers that handled the city requirements, safety there. But right now, before until that happened, it would have. The FAA may have federal is needed because we cross state boundaries. If you don't have state boundaries involved, we could create a local flight safety municipality. Instead of federal aviation, it could be local aviation. It'd be LAA, Local Aviation Administration, and that That would be maybe the San Francisco Bay Area, because you're still among many cities. So you're crossing counties. So it might be state of California is in charge of all that, since you're just staying within the cities.
Are there plans for any of this now?
We are making recommendations to the FAA. We are working with Uber. Uber is involved. My friend Dr. Prevost has gone to Uber, and he's working with Uber to work this out. We need private industry to put the pressure on Congress. Congress needs to initiate too. We need all sectors. We need private industry. We need Congress. We need the people saying, I can't get to work. Let's get behind the flying car idea. So the flying car as a commuter within cities. Here it is already working in rural areas. Some very wealthy people are hoping to fly them. We have helicopters already landing on roofs within cities. So we already have a model that is an FAA approved model for traveling into cities. And they have to have but they have to have a authorized pilot. So that this would get around that, because you would simply be having the computer fly it, but the computer will be talking to the FAA and getting approval.
Okay, the next question. What about taxi services that can take people from like their house to the airport, really, really quickly? What do you think about those services, like in the near future?
Well, what we have right now is Uber Elevate. If you go to Uber's website and type in Uber Elevate, or just type in Google Uber Elevate, it will show you Dr. Prevost's 10-year plan to get the flying car going. And Uber, possibly Lyft could pick it up too, but we need a company, at least one, to get the ball rolling on this. So if we don't have the ball rolling, Congress needs to get behind it too. Maybe we should get some flying cars over in Washington, D.C., help them get safely to different points to get them to like the car. But the taxi service idea is that Uber would buy the car for you, because $250,000 is dollars, what they're going for right now, is too expensive, and they buy a lot of them. That'll bring the price down so more of us could have them. But the idea is, let's say you've got to get to the airport quickly. The Uber could send the car to your house and fly you to the airport. As long as the airport is within 25 miles, as the bird flies, you could get there immediately. So the taxi service, and most cities have an airport within 25 miles of the city downtown. So let's say you're in San Francisco, executive goes to the roof, gets in the flying car, buzzes right to the airport, and that would provide the service. Then Uber would either have a parking spot there at the airport where it would recharge, or if it's not too far away, could take another customer to another local place, as long as it had enough battery strength. Right now, the current battery strength is about 20. You can go 25 miles safely. 25 miles is 25 minutes. It's because the car is going at 20 or 62 miles an hour. So you think, well, 25 miles in a car is not that far, but would be a lot longer to get to the airport. But the reason is, it's as the bird flies. So in the Bay Area, you fly in Danville, you're flying up over a mountain. They have the mountain ranges right there. The Caldecott Tunnel goes through it for cars, but you don't have to worry about the bridge clogging up, and you just zip right over the bridge, right straight into downtown, right into a high-rise building where you can have either a parking garage in one of the layers. And having a parking garage in one of the layers, you'll have maybe a parking spot there. Or it could have a ledge built out there where you just have to land the car and you get out and the Uber car would fly away. So if you have a taxi service, as Murray was asking about, then it's easier because you don't have to have all those parking spots. But Uber would need a charging station somewhere nearby, so that they have to land the car somewhere. But most places could have a parking spot for the flying car where it could park and let you out and then fly to a charging station.
But what about the conflict between drones and the flying car, like drones delivering packages or things like this, and flying cars.
Okay, well, that's it. Uber could get involved in delivery service too, and a drone that would carry a package. Amazon is already talking about that. Pizza delivery could fly to your door. And if we imagine a pizza delivery, how would that happen? A pizza delivery might say, you call the pizza company, you get your pizza on order. They say, we are now going to deliver it. Have your phone ready, and you have your cell phone. Then you can watch and guide where the helicopter should land. But the drone would be driven by an employee of the pizza delivery service, and they would watch where it would land. They would have cameras, pointing to the ground, and the person would be there to make sure their cats, dogs, children are out of the way, and that they give permission for it to land. Then they could take the pizza out, make sure the pizza is okay, and then all tips and payment would all be done on the phone, and credit would be given.
So that would have to be safetied by the same organization that would deal with flying cars. So you can't have a conflict between the flight plan of a drone and a flying car.
That's true. The FAA, or right now it'd be the FAA. So if you fly a drone over a city, the position, the GPS position would be tracked. The FAA would see it on their screens. They would also see the flying cars on their screens, and they would make sure they would not come in conflict with each other, maintaining separability. So one would not run into another. Now, if you have multiple drones buzzing around, two pizzas delivered to the same spot, maybe two brothers saying, I want this pizza, I want that pizza, they both buzz along, then the FAA would make sure they have maintainability. They send a signal back saying that you have to fly at this altitude. Say one's flying at 70 feet, the other one's flying at 100 feet. And they would keep it low, but you still have to fly high enough to avoid all wires and things like this. So all of that, all of those dangers need to be outlined so that the flying cars would fly at high enough altitude. Maybe they fly at 100 and 150 feet, thereby making sure they don't hit power lines and taller buildings, things like this. So yes, they have to have severability, and that's done by the GPS positions being broadcast back to the FAA. And so the FAA would say, oh, these two are getting in conflict, and fix it. And largely that would be done autonomously by computers. So the computers would say, have an algorithm that compares their distance, compares their altitude, and say this one has to be moved here, this one has to be moved there. And that is definitely how it would have to work.
So this would be AI, right?
Yes, AI, artificial intelligence, that's right. Complete autonomous flight. But the FAA would be still in charge of it, and they'd be monitoring it to make sure the computers are operating properly. But the trajectories, the flight paths, they would have to be monitored so they didn't come in conflict. The computers would alert you to problems, but they would also be self-correcting. But the FAA could say, well, I don't like that correction, and could override it.
Well, is the technology there?
Yes.
Now?
The technology is all there. It's just a matter of doing test conditions and seeing what are problems. I hate to bring this up, but they had the self-driving car down in Arizona, and the guy was not watching. They had a guy who was in the car. He should have stepped on the brake, but he's not paying attention. The car is a self-driving car. It was driving itself, and he didn't step on the brake, and a lady pulled out in front of him. And this video went viral. So it was at night, and there were cars, and all of a sudden, 1 minute she was there, 1 minute she wasn't there. And so self-driving cars is a little bit more difficult because of so many people around. One way of making the self-driving car work would be every single person would have to have a phone or device that broadcasts their position, so the self-driving cars say, oh, there they are, they're coming my way, I will slow down and not hit them. So that's probably a little unrealistic at this point, because not everybody wants one of these tracking devices. Every cat, dog, child would have to have these devices on them. So it's different than the drones in the air. And that's the wonderful thing about the drones in the air. Each one of the drones and flying cars will have a transmitter transmitting its GPS position, so they know exactly where they are, avoiding conflicts.
Okay. Well, are you optimistic that something will be ready in about 10 years?
I'm optimistic, but we need people to do it. And Uber is working on it, and NASA needs to work on it. NASA is working on it, but we need more funding. We need more impetus. We need public support. And so that's why I'm making this video, is because I'm trying to engender public support. Because we are Americans, we the people, by the people, for the people. That's our Constitution. That is what we're about. We take initiative. We are the leaders of the world. We can put this together. And I'm very optimistic. However, we still need people to get behind this, and we need your support. And I'm not really being paid for this, but I do it as a public service because I'm enthusiastic about the flying car.
Okay, thank you very much. Okay, I have a quick question about an entrepreneur. I want to start building flying cars. What can NASA do for me?
Okay, what NASA does is we work out the science of it. So you may say, gee, I'd like to fly my car into San Francisco. That's where we are, near San Francisco. How do I get my car into San Francisco? I would say you'd have to contact the FAA. Now here's the thing. We will meet with you. We can also get the FAA to meet with you. And we'll discuss how to do it. Right now we have helicopter rules. FAA supports helicopters. So you can get permits to fly into the city using helicopter rules. That would be for, bigger businesses tend to do it. They have a spot on their building where they can land. And most people don't do it because helicopters are expensive. And you have to, one of the things that makes it extremely expensive is a highly trained pilot. So with the flying car being autonomous, you don't need to have that expensive pilot. So that's one of the things we advise you. You don't need an expensive pilot. Right now, the Blackfly car is one single seater. And so it's really a commuter car or, small cargo. And it doesn't need to be piloted. So if we made these autonomous, they could also handle loads. So you as an entrepreneur could say, hey, I just want to deliver a package to someone in the middle of San Francisco. I'm out at the airport. I just received it off the FedEx truck. I want to deliver it to my business. Can't I just do this? How, as you as an entrepreneur, can accomplish that? You would say, I want to ask you, NASA, how I can do this. We would say, get a helicopter permit, and then get your vehicle. Let's say you're manufacturing. If you're manufacturing a flying car, you will have to meet the FAA guidelines for flight. It has to be a stable airframe, so that very, very low likelihood of crashing. One of the things that we're looking for in the flying car is, and this is FAA, mean time between failure, and mean time between maintenance. So because your maintenance cycle, you have to make sure everything's maintained. Making sure your motors are redundant, so that if you lose a motor or a propeller, all the rest of the propellers still keep you in the air. What's the odds of 2 going out? We have to have enough propellers that they don't go out. You want to also have your flying car so that the propellers are not all based on one controller. They will spin. If the controller goes out, all those things still need to keep spinning and have some sort of emergency procedure for it to land if the controller goes out. And the controller being that which steers it. Those would be completely terrible malfunctions, but machines break. So as long as it's low, as long as the statistic is low, you are going to be fine. Look at the statistics of car crashes right now. Now, what's different about the flying car is, well, they could fly down they could be quite an explosion. We have aircraft that do land on people's houses, and it's devastating. A crash may destroy the entire home. So, but as long as you keep the incident level down and keep the number of car crashes low, they will be the same death rates. I personally believe that flying car will be far less fatal than our driving cars, our on the ground driving cars, because we have 5,000 fatalities a year or something. It's a big number of fatalities a year driving cars, and so it's extremely high. I think it's 5,000 per state. I don't know. It's big. I think it might be California, but it's really our car driving fatality is big. So the self-flying cars are going to be away from people, and they're not going to have obstacles that they run into, because we're going to make sure that they fly outside that. So unless someone's malicious, or that's why the FAA will have to be in charge of the rules of flight. So how would we as NASA help? You'll say, well, I've got this idea for my flying car, and you bring it to NASA. NASA can test it, and then we can give rules to the FAA. We can advise the FAA on how to make rules on keeping your car safe so it doesn't fly in an unsafe fashion.
So if NASA tests something for me, won't they want money?
Maybe. Obviously, bring money in. Really, it's a matter of getting Congress behind it. I don't think, as long as we're supportive, and we are supportive of flying car, I'm saying we need to get our wind tunnels ready for helping flying car companies. And we do take money from people to help with the cost of the wind tunnels research or consulting. But if we can get Congress behind it, then they will support it up to a certain amount of money, so that our equipment is very expensive to use. But we subsidize up to a point, because it's cost prohibitive for a single company to use the wind tunnels. We had Boeing. Boeing did a contract with us, and really it was a labor of our engineers to do the experiment. I believe Boeing did, and so they supplied us enough money so that we were able to work on a project, which keeps me employed at NASA. So private industry has paid money that, and you get a contract. So yeah, there's a certain amount of money, but that's negotiable. And what I'm saying is, if you get Congress behind this movement, they will say, hey, we'll give NASA money to help the companies that want to get started in this. They subsidize a Tesla. Tesla is an electric car, and they are behind electric cars for air quality, and so therefore that whole industry is being subsidized. If Congress pulls their money away from Tesla and other electric car companies, they will not be able to survive. So Tesla's working on getting a new model. Hopefully it'll be not subsidized, because we really, really need to have the industry not subsidized. But this flying car might be able to be subsidized. So I think you as an entrepreneur, that's what you need to do. Contact Congress to get behind us. Thank you.